Okay, so let's try an example. We're going to be using the same kinematic equations we've been working with. We're just going to do them separately in X and Y now, and we're going to see if we can link them using time. So let's go ahead and try to figure out how to solve this first question. I like to use this little graphic here to help me organize all my variables. It is a great idea to use something like this to solve this problem. So why don't you go ahead and read the question, pause the video, and try to solve it, and we will discuss a solution in just a moment. Okay, so let's look at the solution to this problem. Asa, while avoiding the police, drives his Honda Civic off an actual cliff. He comes to the edge of the cliff perfectly horizontally at a velocity of 65 meters per second. If he lands 784 meters downrange, determine the following. How long did Ace's car spin in the air and how tall was the cliff? Okay, so a great place to start with solving a question like this is to draw a diagram. That's what I'm going to do. So here, I've got, here's the cliff. Here's my car. And it is going to drive off the edge at an initial velocity of 65 meters per second. And it's going to land downrange, following that curved path towards the ground, landing over here. And that distance that it's going to land away is 784 meters. Okay? So we now are going to be gathering some variables. So let's go ahead and gather our variables. We have variables in the X and variables in the Y. We have position or change in position. We have initial velocity. We have final velocity. We have acceleration. And we have time. Time is going to be the same for both of the directions. Okay. The first part of the question asks us actually to find time. So we're going to be looking for this. Okay. Let's start out by looking at pieces of information we know. The change in X is going to be from here, the edge of the cliff, to here. That is 784 meters, the horizontal distance away that I land. The change in Y, on the other hand, is going to be the height of this cliff. We do not know that yet. We will find it later. Okay, V naught X, our initial velocity in X, and V naught Y, our initial velocity in Y, we can figure out looking at our initial velocity vector. You will notice I'm coming off of this cliff at a 0-degree angle. So I'm coming off at a 0-degree angle. My initial velocity is entirely in the X direction. There is no Y component of my velocity, right? It is all in the X. So V naught Y is going to be 0. V naught X is just going to be 65. Because the initial velocity is entirely moving in the X direction. The other way you can think about this too is cosine 0 is 1, sine 0 is 0. So in other words, it would be 65 times 1 for your X component, or 65, and 65 times 0 for your Y component, 0. So now we have V naught X and V naught Y being 65 and 0. Excellent. Okay, VFX and VFY are going to be the final velocities that our car hits the ground down here at. The problem did not give us any information about that, and that's something that we cannot easily assume. But remember, when we do a kinematic equation, we're allowed to be missing a variable. So we can just solve this using the kinematic equation that doesn't have a VF in it, which, by the way, is kinematic equation number 4. So we will use that later on to determine our variables. Cool. Okay, now last thing, acceleration in the X and in the Y. Where is our acceleration coming from? Well, remember, we're talking projectiles. So the only force of acceleration is gravity. So our acceleration in the X is going to be 0, and our acceleration in the Y is going to be 9.8 meters per second squared. Now here's the thing. In order for this to work, we have to establish a coordinate system. I have to decide what direction I'm going to be calling up and down in terms of positive or negative numbers. I can go ahead and call my positive X direction this way. I'm just going to stick with the classic Cartesian rules. Call this direction the positive Y and call this direction the negative Y. So in doing so, I'm going to put a minus sign in front of this 9.8. Okay, so now we have a lot of the information from this problem. So we want to find time. We have delta x, we have v naught x, we have ax, we do not have vf. That's okay, because like we said earlier, kinematic equation number 4, we've removed a vf from. So we can actually solve an expression for t to find t. And we could do that saying delta x equals v naught in x times t plus 1/2 a in x times t squared. Now, because we have all of our information, we can just plug and chug. So that's 784 equals 65t plus 1/2 0 times t squared. Okay, 0 times t squared is 0 times 1/2 is 0. This whole thing goes away. So we get 784 equals 65t plus 0. That part goes away. So solving for t, we can divide both sides of this by, divide both sides of this by 65 and get t equals 784 divided by 65, which is 12.06 seconds. Awesome. All right, so now that we know what t is, we can work backwards and figure out what our delta y is, our change in our y position. Because the whole time this thing spins in the air is 12.06 seconds. So the amount of time gravity is going to be able to accelerate it is also 12.06 seconds. So let's go ahead and figure out what our delta y is, our change in height. So we can use the same equation, because again, we're missing a vf, and say delta y equals v naught y times t plus 1/2 ay times t squared. So that's going to be delta y is 0 times 12.06 plus 1/2 times negative 9.8 times 12.06 squared. Okay, 0 times 12.06 is going to be 0, plus half of 9.8 is negative 4.9. 12.06 squared is going to be a little bit over 144. 145.44. Equals delta y. This 0 plus goes away. We can say delta y equals negative 4.9 times 145.44, which is negative 712.656 meters. Okay, so now here's a quick question. Why is this number negative? Well, remember, I made my coordinate system negative. So notice I'm calling my origin point 0 here. I'm moving in the negative y direction, meaning that my change in y was down, which is correct. We fell off the cliff. So by calling the down direction negative, the negative sign at the end of my answer here is just showing me that I am moving downwards. I'm moving in the negative y direction, which is downwards. Okay, so again, this is really simple. It's just like solving a kinematic equation in the x direction, or in one dimension, but now I've added a second dimension, and time is shared between those two dimensions. Okay, so let's go ahead and look at our next example.